Okay? Care of these two guys. You remember their names?
Yes.
Yes, who's the first one? Upper left. Sir Isaac Newton. And lower right? Okay. Leibniz or Leibniz. Okay? Now, for some examples. Okay? Because this is going to turn out to be a computational skill. You should know how to get the area, okay, of regions. Using that, it looks like a formula, right? Now, that's going to be the new formula now. As long as it's an irregularly shaped region, you use a definite integral. Now, first of all, I'd like to validate that that area formula, the definite integral, still works even if you have a familiar region. Okay? For example, I take a, this is of height 2, and this is of width 4. A 2 by 4 rectangle would have what area?
8.
It would be 8. You'd have 2 times 4 equals 8. Now, if I'm going to translate that into the xy plane, I should still get an 8. Okay? So on the xy plane, if I have something like this, and I put our 2 by 4 rectangle there, then if this were the origin, class, on the xy plane, this would be the point 4, 0. This would be the point 0, 2. And this would be the point 4, 2. Now, how would my integral look? My integral would have f of x, which is that ceiling. I like to call it the ceiling. No? This is the floor. This is the ceiling. These are the walls. Okay? So for the ceiling is that horizontal line with what equation? Horizontal. So y equals something.
mx plus b.
Y equals? It's constant. It doesn't change. It's horizontal. Y is always 2. So that is y equals 2. So your y equals f of x is 2 all the time for any x. So that's what you put over here. Okay, f of x. And your dx goes there. And you're working on the horizontal, in the horizontal direction from the first value 0 to the last value 4. Okay, now let's do this. The integral of 2, the integral of a constant is the same constant times x, evaluated from x equals 0 to x equals 4. We get twice the upper limit minus twice the lower limit, and lo and behold, we do get 8. So see, it still works. Okay. Even if we put in a triangle or a circle, maybe it would be good to practice the circle here. Okay. Let's say I want at least this semicircle area if the radius is 1. Now for that ceiling, what is f of x? We know that x squared plus y squared is 1. It's going to work for this. No? But if we just want the upper half so that we have a function, we have y equals 1 minus x squared. And we're just going to set up the integral. I won't ask you to solve. We just want to set up. So how is it going to look? It's going to look like what definite integral? You have a definite integral. The ceiling is 1 minus x squared. The width, you take it along the x-axis and you have the very first one and the very last one. But note that there is a very important property exhibited by the semicircle centered at the origin. There is symmetry. This part on the right of the y-axis is exactly the same as the part on the left. Therefore, you can actually say that the area is also, okay, if we get this area, then it's 0 to 1. You have different walls, same ceiling, same floor, except that this is the right side. The left side is exactly the same, so you want 2 of those. Okay? Why are we allowed to do that? Area is additive. So you can get the area from here to there in one shot, or some of you might want to do it this way. This is area 1, this is area 2, in which case you can do it the longer way. You have one integral going from -1 to 0, another integral going from 0 to 1. And then again, someone else would probably want to exploit the symmetry and say, I'll just do it from 0 to 1. That way, I don't have to deal with the negative, and then I just multiply by 2. Now, that will also allow you to get the area of the entire circle. Entire circle area would be whatever this is times 4, right? Or whatever this is times 2. That's the beauty of it if you have something symmetric. Okay. So if area is additive, we can play around with several area problems, and then we will combine. Okay? For example, class, I want you to figure out the area. Okay, it's important also that you be able to sketch, no? If I do it the other way around, no? We've been doing it this way. We see a region, we set up the integral. How about doing it the other way around? I give you the integral, and then you give me a possible sketch. For example, I have 0 to 2 of 0 to 2 of 2x dx. Now, I claim this is the area of some region. Will you give me a possible region whose area is given by that definite integral? Do the role playing. These are the walls, this is the ceiling, and the floor is your x-axis. Okay. There are many possibilities. In particular, I want you to do the region where the floor is the x-axis. What kind of region would have these two as the sides, and this as the ceiling, and the x-axis as the floor? Would someone like to volunteer their sketch? Lester? We have 2x over here. Let's see. If f of x is 2x, that's also like saying y is 2x. So maybe we can try again. Micah. Thank you, Lester, but the appearance of the x here says that that's not the region we're looking for. Okay, thank you, Micah. Okay. Lester, this line over here is what we had earlier. Y equals 2. And that would have worked if there were no x. Right? And that point would have been 2, 2. This would have both the ordinate and abscissa 2, 2. Okay? And this one I will darken a little. Okay, there's your y-axis. X-axis in the positive directions. There's the line through the origin with slope 2. Okay, so that's y equals 2x. And if the region goes from 0 to 2, that means x equals 0 to x equals 2, then yes, that's the triangle we're looking for. Okay? Now, if you just look at it, you know it's a triangle. What do you think are the dimensions? Before we solve. Okay. This is a triangle. With what dimensions? Micah? You're the one who gave us a triangle. Will you give the dimensions of the triangle? What is the base? 2. Okay, with dimensions 2. And the height is? Okay, if that's a 2, if it's on y equals 2x, then the coordinates of this point would be?
4.
Coordinates would be?
2, 4.
2, 4. So that means the height is 4. Okay. So area, using the formula, is 1/2 base times height, correct? And this would be 4 square units. Now let's see how it's going to work with our integral. Okay. You have 2x, and the integral of 2x is?
2.
2x squared. Okay. You copy the constant, and x becomes x squared over 2, evaluated from x equals 0
X.
to x equals 2. And the 2's will cancel out. So what you have is x squared from 0 to 2, which is 2 squared minus 0 squared, and indeed, we get a 4. Okay? So even if you get a regular shape, you put it on the xy plane, the formula will still work. Whether it's the old formula, the familiar formula, or this method. Okay? Now let's do what this method is better suited for. Okay? So if I have y equals x squared, whose ceiling is y equals x squared. Use a definite integral. Show me the definite integral you will construct to find the area of that irregular shape.